The last rays of the sun is shining on my face and setting over La Silla Observatory in the southern Atacama Desert in Chile. Belongs to the European Southern Observatory. This is still one of the observatories which is doing astronomical research at the cutting edge, and it's been the oldest observatory of ESO back from 1960s. For the past 2 decades, I've been doing nightscape photography, a passion in astrophotography to combine earth and sky in a single frame. I have used many devices, equipment from small lenses like fisheye to large telescopes, but there were few gadgets that I really enjoyed using, and those were the most portable, the smallest and most efficient. A nightscape photographer needs to travel a lot to locations where landmarks, either historic or natural attractions, can be merged with the beauty of the night sky. Some of these are at extreme conditions, high altitude, dry deserts, and therefore smallest equipment, those which are very efficient, can be very useful. Besides a sensitive camera, a fast lens or a telescope, and a good tripod, one of the essential equipment for any astrophotographer is usually a tracking mount. These trackers can be as large as those who are inside these large observatories, several tons each, to as smallest like Polarie by Vixen, one of my favorite devices which can be packed in any small backpack. I've used my Polarie for many locations around the world. It's now been, since the last few years, one of the essential equipments I always have in my backpack because of the portability at one side and then the efficiency of the device that can be used quite quickly, can be arranged with the camera in just a few seconds, polar alignment, and all these in the kind of ergonomy that I like. But why the tracking drive is essential for earth and sky photographer? When you're doing serious nightscape photography, you very often like to go deeper than usual regarding the details of the night sky you can capture. The Milky Way can be brightly appear, especially in such a dark location in the middle of desert where you're far from light pollution. In these cases, you need to capture more photons of the night sky. Well, there are several ways to do that. First is bringing up the ISO, or the performance of the camera in darkness. But that increases noise, of course, so the signal to noise ratio of your camera drops dramatically as you go to higher and higher ISO. As well, your dynamic range decreases as well. so you can resolve less bright and dark areas close to each other. At the same time, you would notice that the colors are less recorded in your images in higher ISOs. So all these problems can just switch your mind to another option, which is faster lens, wider aperture. But lenses are limited in aperture, so you can go as down as like f2 or even 1.4, but then you realize the quality of the image drops dramatically as well. Especially at the corners, you will see much more aberrations of the lens, color fringe, and vignetting. So all these makes the image rather very poor. On the other hand, there are lenses which doesn't offer you very wide aperture. You get a zoom lens which starts from f number of 4, for example, and therefore you need to boost up the ISO to the number which really is noisy in your camera. But there is a third option too. So instead of going up in ISO or the apparent sensitivity of the camera, instead of opening the aperture to maximum you can also increase the exposure. But then there is another limit made by the Earth. The Earth's rotation is our limit here, because after a certain amount of exposure you realize the stars are not anymore pinpoint in your picture, but they are trailed. So this is the effect of the Earth's rotation, and you can limit this by shorter exposures. Just use this simple equation. If you use 500 to the f or focal length of your lens, then you can approximately get the maximum exposure in second that you can do with your camera. For example, if you use a 24mm lens, which is a kind of a standard for many of night escape photographers who are using full frame cameras, then you realize that the 500 to 24 you approximately have maximum of 20-second exposure to capture the stars in pinpoint and not trailed. But very often 20-second exposure is not enough to capture details of the night sky in rather average ISO. Instead of going to ISOs of 12,800 or 6,400 where the camera performs really noisy, you rather stay with 1,600 or 3,200 and increase the exposure. That benefits you in the final quality of the image, in the higher signal to noise ratio, and that enables you to process the image much better. After you polar align the tracker with the north celestial pole, or here in the southern hemisphere with the south celestial pole, then you can start to track the stars for as long as you can, or the accuracy of the drive allows you. But then there is another limitation. As you track the stars, the Earth is moving, so the landscape becomes blurred after a while. Therefore, there is this special mode on Polarie, half a speed of the normal speed of the tracking drive, or half a speed of the sidereal. So that allows you to make an average between the blurring of the landscape and the motion of the stars. And with this mode, you can nearly double your exposure. For example, if you're limited by 20 seconds using a 24mm lens, then you can expand exposure to 40 seconds, and this is a major step forward to capture more details of the night sky without losing much of the image quality, because you're still on the same ISO, same aperture. You just increase the exposure, which enables you to go much deeper and have a good quality image to process as well. The sun is already set over this part of Atacama Desert, so the observatories in La Silla are preparing for a night of exploration, while the night-escape photographer is getting ready for an adventure at dark. You might have seen night-escape photos of the Milky Way or constellation in the sky, which is full of stars. But many of these images lack one point, and that's the dynamic range, the natural colors, natural contrast. Because when you're not using the method of longer exposure and you just switch to higher ISO or wider aperture, then the image quality gets poor. And with such a quality of the image, when you're processing, you end up with a lot of white saturated stars caused by the high ISO. So that's why many of these images, it shows high contrast night sky imagery over landscape, has captured a lot of white stars, and they're nearly at equal brightness. And this is not the natural looking of the night sky. Stars are various brightness, various magnitudes, and there are various colors.